Hi everyone. So today we're going to be going through some more problems on the equations of lines. So lines being parallel, lines being skew, intersections of lines, and so on. Okay, so let's take a look at the first problem. Number 1. Find the equation of the line that passes through we've got 2 points here, 2, -1, and 3. And another point, 1, 4, and -3. Okay, so we've got these two here, and we want to work out the line that goes through them. Okay, so first we need to find that direction vector v. So v is going to be, you can pick any point to be your starting point. So let's say 1, 4, -3. And then we're going to subtract the other points, 2, -1, 3. And this will give us the vector that goes from the first point to the second point. So in this case, we're going to get 1 - 2, that's -1. 4 -1, so that's 4 plus 1, that'll be 5. And then -3 -3, that will be -6. Okay, so that's going to be our direction vector. So now we can just write down the equation of the line. So that's going to be r of t for some parameter t. This will be r0, which is any points along the line, plus t times our direction vector, which is v. Okay, so r0 can be any points along the line, it doesn't matter. So let's pick 2, -1, and 3. So 2, -1, and 3, plus t times our direction vector, we already calculated that. That's going to be -1, 5, -6. Okay, so this is the vector form. Okay, because we've written it out in terms of two vectors, the r0 and the v. We could also write this in those other forms. Remember, we had parametric form and symmetric form. Those were the other two. Okay, so let's work out what those would be. So if we add these two vectors together, we're going to get 2 - t, -1 plus 5t, and 3 -6t. Now, if we identify the first one here as x, the second component as y, and the third component as z, then we can write down the parametric form. So that would be x of t. So x is a function of t. That's 2 - t. Y of t, that's going to be -1 plus 5t. And z of t, that's going to be 3 -6t. So these are our parametric equations. Okay, so that's just another way of writing down the equations for the line. Okay, and then the third way is the symmetric form. So that is when we take our parametric equations, we solve for t, and then we make everything equal. So if we solve for t in the first equation, we're going to get 2 - x is equal to t. So that's from the first equation. From the second one, we can solve for t, and that's going to be y plus 1 divided by 5. It's going to be equal to t. And from the third equation, we can also solve for t. That's going to be 3 - z divided by 6. Okay, so with each equation, we have solved for t. So the first one, the second one, and the third one. Now that all of them are equal to t, it means that they are all equal to each other. So we can write down 2 - x is equal to y plus 1 over 5, which is equal to 3 - z over 6. Okay, and this is the symmetric form. Okay, and notice again, there is no more t parameter. So the symmetric form doesn't have any parameter to it. Okay, so those are the three ways that you can write down the equation. So in the tutorials or the tests or whatever, I can ask for any of these representations. So you can write it in the vector form, the parametric form, or the symmetric form. You need to know how to write this down in all three cases. Okay, let's have a look at the next problem. Problem number 2. Determine if the line that passes through okay, we've got a point 0, -3, and 8. So it passes through that point and is parallel to another line, so a second line given by x equals 10 plus 3t, y is equal to 12t, and z is equal to -3 minus t. Okay, so the second line is given in parametric form. Okay, so does the first line pass through the plane xz, or the xz plane? Passes through the xz plane. Okay, so first let's figure out what the equation of this line is, and then we can see, does it pass through this plane or not? Okay, so we're going to start by rewriting this second line, this L2. Okay, write that a bit better. So that's L2. So we're going to rewrite that a bit nicer so that we can use the vector form for both lines. Okay, I'll make it a bit easier to compare things. So for L2, we have x is equal to 10 plus 3t, y is equal to 12t, and z is equal to -3 minus t. Okay, so we can write this as a vector just by noting what each component is. So we can write this as x, y, z as a vector, and then just substituting. So this is going to be 10 plus 3t, 12t, and -3 minus t. Okay, now we want this to look like that r naught plus t times v. So let's separate out the t part. So this is going to be 10, 0, -3, plus 3t, 12t, and minus t. So everything with the t, I've separated that out. Now we can factor out the t. So this is going to be 10, 0, -3, plus t times 3, 12, and -1. Now this bit over here, this is going to be our direction vector, v. Okay, so that's for the line L2. But we know from the question that it says that our line L1 is parallel to the line L2. So if it's parallel, it means they have a common direction vector. So if this is the direction vector for L2, then it's also the direction vector for L1. So L1, we can write as r of t is equal to, well, let's write it as r1 of lambda, just to use a different parameter. So we can use t for the second line and lambda for the first line. Okay, so this is going to be equal to some point along the line. Well, we've got that here. We've got the point there. So 0, -3, 8. plus lambda times the direction vector, but we know that they share the same direction vector, so that will be 3, 12, minus 1. Okay, so this is our equation for the line L1. Let's put that in blue. Okay, so we've got the equation for the line L1. So now we can answer the question, does it pass through the XZ plane? Okay, so does L1 pass through the XZ plane? Okay, now that's the same thing as asking, is the Y component ever 0? Because if you're going through the XZ plane, it means Y is 0. So does the Y component ever become 0? Okay, so we can check that. If we look at the Y component here, it's going to be this minus 3 plus 12 lambda. Is that ever 0? So let's see. So Y is equal to minus 3 plus 12 lambda. We want this to be 0 so that it goes through the XZ plane. We can solve. So 12 lambda is equal to 3. Lambda is equal to 1/4. So at this value of lambda, the line will pass through the XZ plane. So at this value of lambda, the line will pass through the XZ plane. And if we want to know the exact point at which it passes through the plane, we can just substitute that value of lambda. So the point is R1 at 1/4. So we just substitute 1/4 into that equation. So it will be 0, minus 3, and 8, plus lambda, which is now 1/4, times the direction vector, which was 3, 12, minus 1. Okay, we just add all of that together, and we get ourselves 3/4, 0, which is good because we wanted the Y part to be 0. And the Z part is 31/4. Okay, so that is the point of intersection between the line L1 and this XZ plane. Okay, any questions so far? Okay, let's have a look at the next problem. Problem 3. Okay, so a line is given by x equals 9 plus 21t, y is equal to minus 7, and z is equal to 12 minus 11t. Okay, so we're given the parametric form for this line. Okay, does it intersect the xy plane? Okay, so if it's going to intersect the xy plane, then an equivalent question is z ever 0? Is z equal 0 for some t? Okay, so that's an equivalent question to ask. Okay, so let's work it out. Can this line ever go through the xy plane? So the same question, if we take z, which is 12 minus 11t, and we set this equal to 0, do we get some valid solution? So let's see, we can solve this. So 11t is equal to 12. So t is equal to 12 over 11. Okay, so we do get a solution. So this means when t is equal to 12 over 11, then the line is passing through the xy plane. So at what point does it pass through the xy plane? Or at which point does the line pass through the xy plane? Okay, so we want to know what is this point of intersection? Okay, well, that's easy to do. We've got our value of t, so we can use that to find the x, y, and z values. So remember, x was equal to 9 plus 21t. Okay, and if I substitute this value of t, we're going to get 351 over 11. Okay, so this is at t equals 12 over 11. Okay, we can do a similar thing for y and z. So y is going to be, we look back here, minus 7. Okay, so that doesn't change with t, so that's fixed. And lastly, z is equal to 12 minus 11t. Okay, but again, if we substitute 12 over 11, we get 0. Okay, which is good because that's what we wanted to show, to show that the line goes through the xy plane. So if we put all of that together, then the point, let's call it P, is given by 351 over 11 minus 7 and 0. So this is the point of intersection. Okay, any questions so far? Okay, let's have a look at the next problem. Problem number 4. Okay, determine the intersection point of the lines. And we're given 2 lines, so L1. Okay, this is given by the line through, and we're given 2 points, 1, minus 2, and 13. And 2, 0, minus 5. Okay, so we're not given the equation of the line, but we're given 2 points, and that's enough to find the equation of the line. So that's fine. Okay, what about L2? Okay, so this is given by R2 of t, and this is going to be given by 2 plus 4 times t, minus 1 minus t, and 3. Okay, so we're given the parametric form of L2. Okay, we want to know what is this intersection point between the 2 lines. Okay, so let's get both of them into the same form. So we can use the information from L1 to find the vector form of L1. Okay, so how do we do that? Well, we need a direction vector v. So let's say this is going to be 1 minus 2, 13. So one of the points minus the other one, 2, 0, minus 5. And this is going to give us minus 1, minus 2, and 18. so that is our direction vector. Now we can use that to find the full equation of the line. So R1, let's say of lambda, so we don't mix up the t and the lambda. So t will go with line 2, lambda will go with line 1. Okay, this is going to be equal to some points along the line. Let's just pick the first one. So 1 minus 2, 13, plus lambda times the direction vector, we just worked that out, minus 1, minus 2, and 18. Okay, good. So we've got R2 in vector form, and we have R1 in vector form. So what we want to do is make these two equal, because that means they are intersecting. So when R1 is equal to R2, we know that there's an intersection point there. Okay, so let's do that. So we want R1 of lambda to be equal to R2 of t. Okay, again, lambda goes with line 1, t goes with line 2. Okay, we need different parameters because they're different lines. Okay, so on the left-hand side, we've got 1 minus 2, 13, plus lambda times minus 1, minus 2, and 18. On the right-hand side, we've got 2 plus 4 times t, minus 1 minus t, and 3. Okay, let's make both sides a single vector. So it'll be easier to work with. So on the left-hand side, we can combine these two. We can write 1 minus lambda, minus 2 lambda, and 13 plus 18 lambda. Okay, and this is equal to 2 plus 4 times t, minus 1 minus t, and 3. Okay, now we can look at the individual components. So we've got the x components, that's the first one. We've got the y component, that's the second one. And we've got the z component, that's the third one. Now, if these two vectors are equal, then each of the components must be equal. So that gives us 3 equations to work with. So the first equation, 1 minus lambda, is equal to 2 plus 4 times t. We've got equation 2, minus 2 lambda is equal to minus 1 minus t. And we've got a third equation, 13 plus 18 lambda is equal to 3. Okay, so we've got 3 equations and 2 unknowns, or 2 variables. So 3 equations and 2 variables. Okay, so this could give us a unique solution, which is what we're looking for. However, this could also be inconsistent. If it's inconsistent, then there is no solution, and so the lines don't intersect. Okay, so we need to be careful when solving these. Okay, so check out for consistency when you're solving. Okay, so let's try and solve for lambda and t. We can use the third equation to solve for lambda. That'll be pretty easy because there's just lambda, there's no t values there. So 13 plus 18 lambda is equal to 3. We can take the 13 across, we get 18 lambda is minus 10. And so lambda is minus 5/9 if we simplify that. Okay, so we've got our lambda value. What about our t value? So you can substitute this into either equation 1 or 2, okay, to solve for t. It doesn't matter which one. So let's substitute it into the first one. So we're going to have 1 minus lambda, that's minus 5/9, is equal to 2 plus 4 times t, which is what we want to solve. Okay, so 1 plus 5/9, we can write that as 14/9. 2 plus 4 times t. We can take the 2 across and we get minus 4/9 is equal to 4 times t, divide by 4, So t is equal to -1/9. Okay, so we got a lambda value, we got a t value. Now you can check if the system is consistent. So substitute into all three and make sure that it's consistent. Then you know that these values are fine. Or you can substitute them back into the equations, the initial equations here for R1 and R2, and check that we get the same points. Okay, that's the same sort of thing. Okay, so substitute lambda and t to find the point of intersection. Okay, so you can substitute it into what we have here, 1, 2, and 3, or you can substitute it into the original vector form. Okay, it doesn't matter which one you use. Okay, so let's do that. So we can say check. Let's do R1. So line 1 is given by R1. We can substitute our lambda value. So that's -5/9. And if we do that, we're going to get 1, -2, and 13 -5/9 times -1, -2, and 18. Okay, so we can simplify. Okay, we can simplify this down to 14/9. The y value will be -8/9. And for the z value, we're going to get 3. Okay, so that's for line 1. What about line 2? So for line 2, we're working with R2, and we can substitute our t value there, -1/9. Okay, let's see what we get. So that's going to be 2 plus 4 times -1/9. So that's a 9 there. -1 minus -1/9. So careful with the double negatives there. And 3. Okay, if we simplify this, we're going to get 14/9. Okay, which is good. That matches up there. We're going to get -8/9, which also matches, and 3. Okay, so L1 and L2, they give us the same point. So tick and tick. Therefore, what we've done is correct, and this must be the point of intersection. So therefore, the point of intersection is, let's call it P 14/9 minus, sorry, that's an 8, -8/9 and 3. Okay, so if we just go back up to the system here, if this system here was inconsistent, then we wouldn't have a point of intersection. So just a note. If the system is inconsistent, then there is no intersection. And everyone should be able to check for consistency. Okay, so you check for consistency, and that will tell you if there's an intersection point or not. If it is consistent, then you can substitute your answers back, and you can find the point of intersection. Okay, any questions on this problem? Okay, no questions. Cool. So we'll leave it at that for today. So remember tomorrow morning, we've got that lecture period in the morning. Then we have an online tutorial session. So if you have any questions about the test coming up, remember that's in the afternoon. Please attend that online Zoom session, okay, just to ask your questions. And then in the afternoon, we have our in-person test session, okay, from 2:10. Okay, if you do have additional questions, we can go through that before the test. But if everyone wants to start at 2:10, then we can do that, and then we can finish early. Okay, so that's up to the class. Okay, but I'll see you all tomorrow. Okay, and if you do have any questions, please just post them on the WhatsApp group, or you can email me. And the tutors are also available. Okay, bye everyone.